the Zimbabwe craton rose up and through plate tectonics collided with the Cradle craton. That had the effect of causing expansive areas in the Cradle craton to rift and subside. And that created expansive, shallow seas. But those seas lapped up against a continental landmass totally devoid of life in an unbreathable atmosphere. 60% carbon dioxide, 40% mostly nitrogen, and some other bits and bobs. For our species was the controlled use of fire. That meant we could move out of the trees and into the caves. We could cook food, we could soften vegetable matter, we could cook meat. We could get more nutrition out of our landscape with fire than without. And these are all very important steps in our evolution. And you can imagine clans of our ancestors in rock shelters or in caves around a fire for warmth, for cooking, for protection against predators. And in that process, we became a more and more socially sophisticated animal. That led to the evolution of our frontal lobes. The process of fossilization taking place. When you get sand and leaves, with stones and bones, you've got this mineral-rich water leaching out of the dolomite. It drips onto it and turns it into breccia. Breccia is the Italian word for concrete. Now, that bone will get covered in about 15, 20 years. You can already see the lime-rich water is seeping through the ground, and then it will actually replace the organic material in the bone with calcium carbonate. So bone is calcium phosphate, it gets replaced by the calcium carbonate, and the fossil is actually an exact mineral replica of the original organic bone. So these little stalactites that are forming are in fact 100 years old. So that'll give you some visual indication of how quickly these things form, or rather how slowly. And then the truth of it is that this is a very fast geological process. So fast is a relative term.
As we are busy prepping here, we will see where the bone actually ends.
This is not exactly speedy work.